Hi students, in this video I'll be going through the 2016 O-Level Paper 2 question 6A and 6B. Alright, so let's read the question. Right, so the diagram shows two concentric circles, center O. So concentric means that the two circles, the small one and the big one, they share the same center, right? So A, B, and C are points on the larger circle, and D is a point on the smaller circle. ADB is a tangent to the smaller circle, and angle BCO is equals to 65 degrees. Okay, so for part A, they want us to show that triangles ABC, okay, so the big triangle, and ADO are similar. Okay, give a reason for each statement you make. Alright, so over here they want us to prove that this small triangle, okay, over here, ADO, right, is similar to the bigger triangle ABC, right? So prove similarity. Okay, so we need to recall what are the different tests for similarity that we know of. So one of it is SSS, right? Alright, so the first test of similarity. Okay, the second one is SAS, and the third one is of course AA. Alright, so we need to decide which of these tests is most likely for this case. Okay, if you look at this question, we are not given any lengths. Okay, likelihood, most probably the only length that we know of is the radius, right? AO is the radius of the circle. Okay, and the corresponding side, AC, okay, is the diameter of the big circle. Okay, so which means that AC will be double of AO. Okay, so we know one ratio. Okay, but in order for us to use either SAS or SSS, right? We need more than one ratios of corresponding sides. So in this case, it's likely that we can only use AA to prove similarity. Okay, so we should start to search for angles, okay, in order to prove that the two triangles ADO and ABC are similar. Okay, so over here you have a tangent. Okay, so the moment you see a tangent in the question, you should be thinking about the property tangent perpendicular to radius, right? And indeed, we have a tangent ADB that is perpendicular to the radius OD. Okay, which means that this angle ADO will be 90. Right. So are we able to find a corresponding 90 degree in the bigger triangle or not? Okay, then we will be able to find, right? You see, the moment you see the diameter AC, you should be thinking about the property right angle in a semicircle, because the diameter always cuts the circle into two semicircles. So indeed, we have a right angle in a semicircle over here. Okay, so this will be one pair of angles, okay, that we can talk about already. Okay, so let's go ahead and write down the working. So for 2A, we can say that angle ABC is equals to 90 degrees. Okay, so this is because it's a right angle in a semicircle, right? Okay, then we can also say that angle ADO is also equals to 90 degrees. Okay, and this is the property tangent perpendicular to radius, right? So tangent perpendicular to radius. Okay, so now we have one pair of corresponding angles ready. Okay, therefore angle ABC is equals to angle ADO. Right, so this one angle already. Okay, so now we just need to find one more pair of equal angles, and then we will be able to prove similarity. Okay, so whenever the two triangles are overlapping, you see ADO, right, is overlapping on the big triangle ABC. So there will be a common angle over here, and this common angle will be the second pair of corresponding angles. So what we can write is angle BAC, okay, is equals to angle DAO. Okay, this is a common angle. Okay, common angle. Okay, and hence we can prove similarity already. Therefore, triangle ABC is similar to triangle ADO, and the test that we are using here is the AA test. Right, so we have proved similarity already. Okay, so not too difficult of a question. Okay, let's look at part B. Okay, part B, they want us to find the ratio of the area of triangle BOC. Okay, so BOC is over here. Okay, this triangle. Okay, the ratio of this area, okay, to the area of triangle ADO. Okay, so ADO is over here. Okay, so whenever you come across questions that is regarding similarity, and they ask you to talk about areas, okay, there's one question that you need to ask yourself. Okay, are the two triangles that they are asking you to prove the ratio, to find the ratio, right? Okay, are the two triangles similar or not? Okay, if they are similar, right, then we can use the property, the ratio of areas of similar triangles will be equals to the ratio of corresponding sides squared. Okay, by this case, you can see that these two triangles are obviously not similar. Right? They are not similar, so you cannot use that particular property. Okay, so if they are not similar, then you should be looking for common height. Okay, so basically there are two ways to approach this question. Either is if they are similar, you use the ratio of area equals to ratio of corresponding side square. If not, you try to find a common height between the two triangles. Okay, but as you can see from here, these two triangles are actually uh, not together. Okay, they are not like side by side or what. So it's very hard for them to have a common height, right? Okay, we can't be taking this to be the height. Okay, then obviously it's not a common height. Okay, the height over here, h1 is definitely greater than h. Okay, so the common height cannot be over here. Okay, so now if you look at the figure, right, are you able to identify another triangle okay, that has the same area as ADO? Okay, and maybe this triangle has a common height with triangle BOC. Okay, so you should be able to notice or at least have a clue, right, that maybe triangle ADO has the same area as triangle BDO. Okay, because they look almost the same, right? Okay, so we need to actually verify this fact. Okay, so over here you can see DO is the radius, right? So the radius is perpendicular to the tangent. Okay, but then the radius is also coming from the center, and AB is also a chord to the bigger circle. Okay, because both ends of the line AB, right, terminates at the circumference of the bigger circle. So AB is a chord. So over here we can apply the property, right? Perpendicular from center bisects chord, meaning this one is the same length as this, right? Then of course this is a perpendicular line DO. Okay, so both these triangles have the have a height, have a common height, right? Have the same height, and they are both right angle triangles. So according to half time base time height, okay, these two triangles, okay, they have the same base length, right? AD is equals to a BD. So triangle ADO has the same area as triangle BDO. All right, so let's write down this thing first, and then we see how we can relate to whatever they want us to find, right? In the end, they want us to solve for area of triangle BOC is to area of triangle ADO. Okay, so now we have identified that area of triangle ADO is equals to area of triangle BDO, right? BDO. Okay, so this is because actually a triangle ADO is congruent to triangle BDO. Okay, so if you are congruent means they have the same shape and the same size, right? Okay, because over here you see AD same length as BD. Okay, this height is also the same, and then the angle here is the same. So by SAS congruency, these two triangles are congruent. All right. Okay, so that's one thing. All right. So in this case, they want us to find area of the ratio of area of triangle BOC, right, to area of triangle ADO. But now ADO has the same area as BDO. Okay, so area of triangle BOC is to area of triangle BDO. Okay, so remember just now I was mentioning we are trying to find a common height. Okay, so now the question has been changed already. Okay, now we want to find the ratio okay, between BOC, okay, this triangle, okay, and BDO now, okay, this triangle. Okay, so remember this 90 degree, here is also 90 degree. Okay, so do these two triangles have a common height now? Okay, so if you were to draw a perpendicular line down here, Okay. These two triangles now have a common height because area of triangle BOC, okay, taking the height to be here, okay, the perpendicular height here. Area of triangle BOC will be half times BC, okay, the base length times the height, right? And then area of triangle BDO, okay, will be half times the base. Okay, now the base will be DO. Okay, the base of triangle BDO will be DO. Okay, times the same height. Right, so this means that we can actually cancel away the half and the h, and then we'll just get BC is to DO. Right, but what is the ratio of the length of BC is to DO? Okay, if we know this ratio, then we get the answer already. Okay, so now I'm going to erase away all these things. Okay, so you see over here in part A, we have already proven similarity, right, between triangle ADO and ABC, right? So we have already proven similarity. Okay, so now we want DO is to BC, right? So just now we have proven triangle ADO is similar to triangle ABC, right? ABC. Okay, so now we want the ratio BC is to DO. Okay, so BC is to DO, you will realize that is also equals to the ratio of AC is to AO. Right, so we can change it to AC is to AO. Okay, what is the length of AC? Okay, AC is the diameter of the circle. So if I call this R, AC is going to be 2R. And AO is going to be R, right? Okay, so this means that the ratio that we want is 2 is to 1. Alright, so you can see that for a question like this, although it's just a 2-mark question, it requires quite a bit of thinking, okay, quite a bit of planning, and also have to be sharp to notice details. Okay, so but with regards to questions regarding congruency and similarity, okay, for similarity, if they are talking about the ratio, we want you to find the ratio of areas. You look out for whether you think about whether the triangles are similar or not. If they are not similar, then try to look out for common height, right? Okay, so there's actually a part C to this question, which I've already gone through in another video. So I'll put the link in the description so that if you want to take a look at the part C of the question, you can continue watching the other video, right?